Welcome back to Advanced Skills Learning. Most RAG systems fail for a simple but uncomfortable reason: they assume all knowledge is text. In practice, real enterprise data rarely looks like clean paragraphs. It lives in PDFs, scanned forms, tables, charts, screenshots, and diagrams where meaning is carried visually, not linguistically. When we force this information into text-only pipelines, we quietly discard context that humans rely on instinctively. When these visual signals are lost, retrieval may return technically relevant text while missing the actual answer. The LLM then compensates by inferring relationships that were never retrieved. This is why users experience answers that sound reasonable but fail basic verification. That is why text-only RAG breaks. The model is not hallucinating, it's answering based on incomplete evidence. When visual structure disappears, the model fills gaps with guesses, and those guesses often sound confident. The problem is not intelligence, it's visibility. This is where multimodal RAG comes in. Multimodal RAG extends retrieval-augmented generation beyond text by allowing systems to retrieve and reason over images, tables, diagrams, and document layouts alongside traditional text chunks. The goal is not to make the LLM smarter. The goal is to give it access to the same signals a human would use when reading the source material. Multimodal RAG works by representing different data types explicitly. Text gets text embeddings. Images get image embeddings. Tables and layouts preserve structure and relationships. During retrieval, these signals are combined so the system can find the right evidence, not just the most similar sentence. This separation is critical. Mixing everything into text embeddings too early destroys information that cannot be reconstructed later. Multimodal systems delay fusion until retrieval or re-ranking, where the system has more context to decide what evidence actually matters for a given question. Consider where multimodal RAG helps the most. Financial reports often hide conclusions inside charts and tables. Medical records rely on scanned forms, handwritten notes, and structured grids. Architecture documents communicate intent through diagrams, arrows, and grouping, not paragraphs. Text-only RAG either ignores this information or reduces it to a weak approximation. Quick check, 2 seconds. What usually breaks first in text-only RAG? A. Token limits. B. Model accuracy. C. Visual context. Keep your guess. The answer is C. Visual context disappears long before tokens or models become the bottleneck. Ingestion is the first major architectural shift in multimodal RAG. Instead of treating documents as text streams, we parse layout, detect tables, extract images, and preserve spatial relationships. Each chunk carries metadata about its modality so retrieval knows what kind of information it represents. This additional work upfront is what enables downstream accuracy. If ingestion collapses structure too early, retrieval has no chance of selecting the right evidence later. In multimodal systems, ingestion quality directly determines answer quality. Retrieval is where multimodal RAG becomes truly challenging. Matching a user query to an image or diagram is not a simple similarity search. Relevance across modalities often requires separate retrievers, cross-modal scoring, and careful re-ranking logic. This is also where latency and cost can increase if not designed thoughtfully. This is why multimodal RAG success depends more on retrieval design than on which LLM you choose. A strong retrieval layer feeding a modest model often outperforms a powerful model operating on weak evidence. During generation, multimodal-capable models can reason across text and images together. Instead of hallucinating descriptions of charts or diagrams, the model can ground its answer in actual visual references. This significantly reduces confident but incorrect explanations, especially in analytical and technical domains. Importantly, multimodal grounding does not eliminate hallucinations entirely, but it narrows the model's degrees of freedom. The model is constrained by retrieved evidence rather than imagination. Quick check, 2 seconds. What's the most common multimodal mistake? A. Using OCR. B. Ignoring layout. C. Large context windows. Keep your guess. The answer is B. Ignoring layout, because layout is what gives information its meaning. Multimodal RAG is not always the right choice. If your domain is purely textual, such as FAQs or knowledge bases, text-only RAG is often simpler, faster, and cheaper. Multimodal systems add operational complexity, additional storage, and higher retrieval costs. The decision should be driven by data shape, not novelty. If users rely on diagrams, tables, or scanned documents to understand answers, multimodal RAG is usually worth the investment. Otherwise, it may introduce more overhead than value. The key takeaways are these. Text-only RAG is fragile because the real world is not text-only. Multimodal RAG restores missing context by treating images, tables, and layouts as first-class evidence. This improves grounding, reduces hallucinations, and aligns model reasoning with how humans consume information. However, multimodal RAG is not a silver bullet. Its success depends on careful ingestion, modality-aware retrieval, and disciplined ranking. Models matter, but retrieval architecture matters more. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures, and quick quizzes to test your understanding.